This is question 9 of exercise 10b. It can be represented by this triangle where the midpoints of the sides are 5, 4, 8, 5 and 6, 0. We are required to find the coordinates of the vertices of the triangle. So let's call the vertices AB, CD, EF, where A, B, C, D, E and F are coordinates of the vertices. Because we know that the midpoint is 8, 5, we can simply apply the rule. We know that A plus C divided by 2 equals 8, because that's what the midpoint is. So A plus C divided by 2 equals 8. If we take the y coordinate, we know that B plus D over 2 is 5, so this is B plus D over 2 equals 5. And we do the same process for the two other sides. If we take the x coordinates for this side, we have A plus E divided by 2 equals 5, and B plus F over 2 equals 4, and finally, using the same analysis, C plus E divided by 2 equals 6, and D plus F over 2 equals 0. So as you can see, we have 3 pairs of equations. This set contains A, C and D, and this set contains B, D and F. Those are the x coordinates of the points, and those are from the y coordinates of the points. Obviously, in all cases we can multiply both sides by 2 to get rid of the fractions and end up with the variables without fractions. So if we take the first set, we have A plus C equals 16, we have A plus E equals 10, and we have C plus E equals 12. And from the second set, we have B plus D equals 10, B plus F equals 8, and finally D plus F equals 0. Now this tells us that D equals negative F, because D plus F equals 0. Now we notice that we have simultaneous equations, but we have 3 simultaneous equations and 3 unknowns, in this case A, C and E, and 3 simultaneous equations and 3 unknowns, in this case B, D and F. But our first clue is that D equals negative F. So we can take this and substitute it in this equation. So it becomes B, and instead of plus D, we have minus F equals 10. And if you look at this equation and we write it again, we have 2 equations and 2 unknowns. We can solve this by elimination. Simply by adding those 2 equations, we get 2b equals 18, so b equals 9. This is our first solution. Now, if you look at the first equation, b plus d equals 10, and we know that b is 9, so 9 plus 1 equals 10. This gives us that d equals 1. But d equals negative f, or you can say that f equals negative d. Therefore, f equals negative 1. So we've solved the problem for the y coordinates. Let's now deal with the x coordinates. Unfortunately, we don't have a starting point where we have one variable that can be expressed in terms of the other. But we can work on that. Let's take those two equations, the 16 and the 10. A plus C equals 16 and A plus E equals 10. We can eliminate the A and end up with an equation containing C and E, which in turn can be solved with this one. So subtracting those two equations, A minus A, they cancel out, C minus E equals 16 minus 10, which is 6. Now we have a new equation, C minus E equals 6. We take it and solve it with this equation, which is C plus E equals 12. Now when we add those two equations, the e's cancel and we end up with 2C equals 18, giving C equals 9. But consider this equation, for example. C plus E equals 12, but C is 9. This implies that E equals 3. 9 plus 3 equals 12. And again, take, let's say, this one. A plus E equals 10, which is this one. A plus E equals 10. This gives us something plus 3 equals 10, so A equals 7. So our coordinates can now be written as, for this point, AB, which is 7, 9. Let's remove the letters. AB is now 7, 9. CD is 9, 1. And finally, EF is 3, negative 1. And if we check very quickly, 9 plus 1 divided by 2 is 5. 7 plus 9 divided by 2 is 8. 1 minus 1 is 0. 9 plus 3 over 2 is 6. 7 plus 3 over 2 is 5. 9 minus 1 divided by 2 is 4. So we now have the coordinates of the vertices, and we could do that using algebra. We generated a set of simultaneous equations, and what's new about this question is that you have 3 simultaneous equations and 3 unknowns.